Hello, my name is Aaron Balke, and today I want to break down and announce my Guac emulator, an emulator for the Game Boy, Game Boy Color, and Game Boy Advance that I built in Golang. We'll start by going over some features, some of the technology involved, some performance considerations I had to have, some bugs that were a real big pain, and finally what the plan is moving forward. One of the notable features of this emulator is its console mode. So you just fill out the game and artwork locations in a JSON file, and then you're able to just load up a menu screen that allows you to choose different games. It also has like a pause menu to mute or return to the game selection menu. And so we got that going on in there. There's controller support. I've tested it using a DualSense, but it should work with any old controller because it uses the W3 standard gamepad spec, which this was the first time I heard that the web had a gamepad standard, so I assume it works with Xbox and Steam controllers, etc. Controller inputs and keyboard inputs are all configurable in a TOML file. Some additional settings you can change in there are like, does it open up in full screen, what the DMG, the dot matrix Game Boy's color scheme is. You can go in there and instead of using the standard grayscale, you can go in there and switch it up, use your own colors that you would like. One of the complications with building the emulator in Golang was that most graphical and window display libraries are built in C. And so when I originally started out building the Game Boy portion of the emulator, the first part, I was using Go SDL2, which is a library for building bindings and connections to SDL2. And that was working fine, but as I kept on building it out, it obviously got more complicated. And also, there were so many CGO calls being made to SDL from the SDL2 bindings. It also was difficult to cross-compile using static libraries in SDL2 for Go. And so I did end up switching to Ibitingen by Hashime Oshi, and this library is super useful for building anything you need a game loop for, so obviously games, emulators as well in Golang. And the reason it's so handy is it doesn't make CGO calls, and that removes a lot of the overhead over those C bindings. And so it's also easier for cross-compilation. I don't have to worry about static C libraries like SDL2. I've gotten it working on a Linux machine very nicely. I've got it working on my Windows machine. So all of that works really well thanks to Ibitingen and Hashime Oshi. I'm able to get about 400 frames per second on a fairly recent machine. It's about 3 years old, most of the hardware is. So still able to get out 400 frames per second. On the subject of performance, obviously it is one of the harder aspects of building an emulator in Golang is the fact that it's a garbage collected language. One of the places I was able to get a bunch of performance was replacing modulos, which appear all over the Game Boy Advance and the graphics and memory specifically. Replacing those with AND masks. You're able to replace any power of 2 with a AND mask of that value -1 and significantly speeds stuff up, which if you're doing something like memory access that happens multiple times in instruction, you can significantly increase the speed of your emulator. Some other places I was able to get some performance increases was instead of using my memory read function in order to get the PC, I was able to make some assumptions since it is the program counter, the location of the next instruction. I knew it was going to be in the BIOS, the work RAM, or the ROM. And so by making that assumption, I was able to simplify it quite a bit, take it from doing a read instruction against all of the memory. I was able to just directly grab the chunks I needed, and I grabbed those chunks of the array using the binary package instead of grabbing multiple uint8s and then combining them together, so that removed a lot of instructions. Idle looping was a very useful thing as well. In many games, they have a VSync loop, so they'll hit this loop and then they'll wait until a interrupt is called for the end of the frame. And so when you're sitting there waiting for that frame to get hit, inside a actual Game Boy Advance, you would be running the same 6 instructions constantly. But if you know where those places and those loops are in the cartridge, you're able to just say, once you hit this place, wait until you have a IRQ called for V blank, and then it'll just start up again. So you just halt it between those 2 points. That had a massive 30% speed increase. When it comes to just some stupid bugs I had to fix that are caused by me and I spent many a time working on. I had a issue where for some reason I thought I should put a big goose egg, a big 0 in for the write back address of signed byte loads. And for 99.99999% of situations, that does not matter, which is what made this bug such a pain. But when it came to sound loading, the loading of digital sound into the APU from the Game Boy Advance, a lot of games use the load signed byte, and reason is it's a whole lot easier to symbolize a sound wave with negative and positive values, because you're able to have the positive values for the crest and amplitude, and then the negative values for the negative amplitude and the troughs of the wave. For most things in the Game Boy Advance, using unsigned ints makes a whole lot more sense, but with sound specifically, the signed ints are significantly more important. So it only showed up once I was dealing with the sound, and it took me about 2 weeks to get it figured out because of how weird of a bug it was and how it wasn't showing up anywhere else. If it was a different problem that was a problem the Game Boy Advance needed just to function, it would have showed up way sooner. So a real big pain, but it was really fun when I found it. So some other things in regard to the emulation. I tried to start with a high-level BIOS, like build a high-level emulation BIOS where I recreate all the functions in the BIOS inside the emulator itself instead of just using a BIOS file from online. Do not do that if you're building your own emulator. It's quite the pain and real nasty to try to do that on your own. And that's just because some of those functions, such as the LZ77 compression, the Huffman encoding, all of those are a real big pain to try to do by hand and write your own implementation. When it comes to plans for the Guac emulator moving forward, the APU is now a shared APU using Otto, which is a sound library by Hashimiyoshi, and it is using an older version, and I want to fix the bugs that make it hard to use the built-in EBIT engine sound library and sound functionality. So I want to try to get it so there's one less dependency in there, just EBIT engine and not Otto. I want to try to get that working. The sound does need a little bit more work. Channel 3 of the analog has random volume spikes, which is terrifying. So I need to work on that a little bit. Still, as always, games that need to get working. For the Game Boy, Game Boy Color, Game Boy Advance, there are markdown pages dedicated to testing the emulators, where I have breakdowns of the test that it is passing and the games that have either problems or things that need to be fixed, so I can keep track of all of that good stuff. And maybe someday, fingers crossed, I'm kind of wanting to do a Nintendo DS emulator. The Nintendo DS is very similar to the Game Boy Advance. The Nintendo DS, I would actually say, is closer to the Game Boy Advance than the Game Boy is to the Game Boy Advance, and reasons for that are that the Game Boy uses a Sharp CPU while the Game Boy Advanced and Nintendo DS both use ARM CPUs. It's just sort of a beefier version. I have a feeling the hardest part of the DS is going to be eking out more performance, especially since the CPU, depending on the situation, can be 2 to 4 times faster than the Game Boy Advance one, so I'm going to need to get as much performance as possible. The 3D graphics are going to be fun, I think. I think that's going to be really exciting. And yeah, so I'm kind of hoping to do that. We'll see what happens. I think that will be a nice addition for the Guac emulator. And that is Guac, my emulator written for Game Boy, Game Boy Color, and Game Boy Advance games. If you are interested in checking out, you can go to the GitHub page in the description. If you're interested in contributing, you can go there as well and see some resources. And if you're interested in any specific breakdowns on specific aspects of building the emulator, some video tutorials or something like that, let me know and I'll be happy to do them. Thanks for watching and have a good one.